Hi everyone, have you ever wondered how did we measure the radius of Earth? Think about it. Standing on the surface of Earth, it would seem impossible that we would be able to measure the radius of Earth. However, some 3000 years ago, a person named Eratosthenes was able to exactly do that. He was able to determine the radius of Earth without any modern, expensive experimental equipments. So how did he do that? Well, today's video is about that. Eratosthenes was a scholar. He was the chief librarian of a library in Alexandria, and he loved reading books. In one of the books he read that on this particular day, 21st of June, in a place called Syene, which was around 800 kilometers far from Alexandria, the place where he stayed, he found that the rays of light fall vertically. Now, how would he know that? Well, if the sun is directly over the head, then the rays would fall vertically. And if the rays would fall vertically, then in a well, if you look down, you would see the image of the sun. Another way to know that is if you put a vertical pole, the pole would not make any shadow. So no shadow will be formed because the rays are falling vertical. Now, many people would have read about this and they would have forgotten about it, right? What's there, like shadows, no shadows, well. However, Eratosthenes gave a thought to this. He reasoned that such an incident never happened in Alexandria. So to check this, on 21st of June, the next year, he made some vertical poles and he tried to find if the poles make any shadow, and he was surprised that on the same day the rays of light here are actually coming at an angle, and that's because a shadow was formed. So this is the shadow. The angle at which it comes was measured to be 7.2 degrees. This proved that the surface of Earth is not flat but actually curved. But how does it actually prove it? For that I have done a demonstration. Let's see. Hi guys, I am using this surface to represent the surface of Earth. So here you can see two places and two vertical poles. Now this is source of light which I can imagine as the sun. Now if the surface was flat, then you can see if one pole does not make shadow, the other also is not making any shadow if the surface was flat. But if the surface of Earth was curved, then you can see by some adjustment that even if this side, even if this area, there is no shadow cast by the pole, you can see here there is a shadow. So now you are convinced that the surface of Earth is curved. However, with that information, how are we going to measure the radius of Earth? So let's continue. Imagine this is Earth and this is Syene and this is Alexandria. On 21st of June, when the rays were falling vertically on this place Syene, on Alexandria, you can see it is making an angle of 7.2 degrees with the poles. So this is the pole which we have seen in the previous case. This is the pole and this is the shadow, right? So this angle that the rays make with the vertical here is 7.2 degrees. Now from geometry, if this is 7.2 degree, this is also 7.2 degree. That's alternate angles, right? Okay. Now he needed to know this distance. So what he did was he made someone actually walk from Alexandria to Syene and find the distance between the two places. And it was found, the distance between A and S was found to be, during those days the units used were stadia, so it was 5000 stadia. In kilometer, it is approximately 800 kilometers. So from here, to continue further, we need to quickly revise what do we mean by proportions. So proportions, I am sure everybody knows. if 2 apples cost 20 rupees and each apple has same price, then 1 apple would cost 20 by 2, 10 rupees, and 10 apples would cost 10 into 10 rupees, which would be 100 rupees. So the same concept of proportions we will apply here. So we have found that an angle of 7.2 degree corresponds to an arc length of 5000 stadia. In kilometers it is 800 kilometers. So an angle of 7.2 degrees corresponds to 800 kilometers. Right? Okay. That would mean 1 degree, just like this, would be 800 by 7.2 kilometers. However, I am interested to know not only the distance between A and S, but the whole circumference. So for the whole circumference, the angle would be total angle, which would be 360 degrees, right? So in 360 degrees, the total arc length of this circle would be 360 times, like we did here 10 times, 360 times 800 by 7.2 kilometers. 7.25 is 36 with a 0 here, so this would give you at 5 is 40,000 kilometers. So that would be the circumference of Earth. Having found the circumference, now we can find the radius of Earth. The radius of Earth is given by circumference divided by 2 pi. We have seen this formula since school days. If you substitute the circumference, you will get approximately 6369 kilometers. Compare this value with the modern value of the radius of Earth, which is 6371 kilometers. Please notice this, how close Eratosthenes got the radius of Earth to the true value. And he did not have any modern equipment, remember. So, what did we learn from here? What we learned is, if Eratosthenes did not ask himself, if he did not reason why in one place at one time we get shadow and in the same time in another place we don't get shadow. If he had not reasoned, he would not have discovered this wonderful concept.